expressions, you multiply by the reciprocal. Okay, you keep the first one exactly as it is, you flip the other one over, and it turns into multiplication. Now, y'all may be able to do this in one step. That's fine, as long as you don't mess anything up. But for the notes here, I'm going to take the time to write out flipping the second one over and then multiplying. So like I said, if you can flip and multiply at the same time, go for it. Just please be careful. Okay, 5 times 8 is 40. We don't have another p in the numerator, so we just got p, and q times q to the 5th is q to the 6th. In the denominator, 16 times 35, somebody help me out on that. 525, 525? 560, thank you. All right, 560. P cubed times p squared is p to the 5th, and we've just got q squared down there. All right, so let's simplify. 40 over 560, I know they at least reduce by a factor of 10 because they're both divisible by 10, and then 4 over 56, I think is 1 over 16. Is that correct? Or 14, 14. Huh? Divide by 40, yeah, okay. So we get 14, okay, we get 14 in the bottom. P over p to the 5th leaves us with p to the 4th in the denominator, and q to the 6th over q squared leaves us with q to the 4th in the numerator. And that is fully simplified. All right, let's look at number 14. Okay, again, I'm going to take the time. I'm just going to rewrite the problem with multiplying by the reciprocal, then I'm going to factor. Although that step, you may be able to, like factor out a GCF or something to kind of make it worth your while. Okay, so we've got 10 x squared plus x minus 6 does not have a GCF, so 2 sets parentheses, x times x is x squared, positive 3, negative 2. Denominator, you take a 4 out of the first denominator, it leaves us with x minus 2. Times, take a 2x out of the second denominator, leaves us with x plus 3. So, time to cancel. I see x plus 3 in the top and the bottom. I see x minus 2 in the top and the bottom. How about 10 over 2 will leave us with a 5 in the top. So we've got 5 over 4 times x. If you need 2 steps for that, that's fine. If you want to do 5 over 8x, and then, or excuse me, 10 over 8x and then simplify it to 5 over 4x, that's fine. Okay, let's look at number 15. Any problems with number 15 that we see kind of right off the bat here? Okay, the second denominator is not in standard form. So I'm going to flip that around. Okay, the second denominator is not in standard form. So let's flip that around. So now let's bring it down. Don't change the first one. Okay, the first one does not change. It's just like with fractions. The first fraction doesn't change. It's multiplying by the reciprocal of the second one. A squared minus 8a plus 15 over negative 8a cubed plus 24a squared. Okay, now we can factor. First numerator, what's the GCF? 2, just 2? A squared. Okay, 2a squared leaves us with a minus 6. Second numerator, no GCF, so 2 sets of parentheses. A times a is a squared. Negative 5 and negative 3 gives us negative 8. First denominator, a minus 6 times a plus 2. Second denominator times negative 8a squared, right? We don't like negative leading coefficients. And be careful with that. That makes it a minus 3. Any questions about my factoring there? All right, time to cancel. A minus 6, top and bottom. A minus 3, top and bottom. A squared, top and bottom. 2 over negative 8 leaves me with negative 4 in the denominator. So what do we have left? We've got a minus 5 in the top. In the bottom, we've got a negative 4. We don't like those negatives in the denominator, so the negative I'm going to move to the numerator. Notice I kept my parentheses around the a minus 5. And the 4 stays, okay? We can't move the whole negative 4, but we can move the negative in front of it. And we've got a minus 2 left down there. So again, you may see this as negative a plus 5 over 4 times a plus 2. Okay, probably going to distribute that negative as a multiple choice answer choice. Okay, but I'm fine with the first one on your quiz, or whatever. If I ask you to do free response something, as long as there are parentheses around it. All right, last one. We got a little combo going on here on number 16. We've got division and multiplication. So the first thing that I see on this problem is that the expression in the middle is not a rational expression. It's not a fraction. It doesn't look like the other ones. So how about we just make it look like the other ones by putting it over 1. Okay, put it over 1 just so that it has a denominator so it can fit in with everybody else. Okay, but the biggest reason why I do that is because it follows a division symbol. So when we're doing these problems, if it follows a division symbol, then we flip and multiply. If I didn't put that over 1 there, some of you wouldn't actually flip it. It would just kind of stay the same, okay? So flip it and multiply. Now the last one stays exactly the same. We don't do anything to it because it follows a multiplication symbol. We don't change anything that follows a multiplication symbol, only if it follows a division symbol. Okay, so let's see here. What needs to be factored? K plus 3? No. Put parentheses around. 1, multiplying by 1 doesn't do anything. How about 16k squared minus 1? What is that? What do we call it? Difference of perfect squares. So 2 sets of parentheses. 4k times k gives, or 4k times 4k gives us 16k squared. 1 times 1 gives us 1. One of those gets a plus, one of them gets a minus. Denominator. That k, just bring it down. Put some parentheses around the 4k plus 1. Put some parentheses around the k plus 3. Now we get to cancel. So k plus 3, 4k plus 1. We are left with 4k minus 1 over k. I'm sure someone is thinking it. Can't we cancel those k's? What is the answer? No. We cannot cancel those k's because of that minus 1 right there. My minus doesn't very much look like a minus. That is supposed to be a minus. Sorry, it came from right here. Okay, 4k minus 1. If that was 4k times negative 1, sure, we could cancel those k's. But it's 4k minus 1. We can only cancel it if it's an entire factor. Okay, so that's all we can do on that problem right there. All right, so here